Hello everyone, and welcome to the last lecture in the GUI bonus section of this course, where we discussed widgets. And in the introduction lecture, we discussed various GUIs. It was just a written portion, some notes there for you to review. Go ahead and go back and review those. Make sure you understand the full ecosystem and GUI possibilities you have out there. For instance, if you want to do data dashboards and what we've learned so far about widgets, will make a lot of sense to use. If you want to program 2D games like Tetris, you'll probably want to explore Pygame, 𝗠𝗲𝗁𝗍. And if you want to do such things like web development and do GUIs on that end, you may not end up using Python at all in the front end. You'll probably use something like JavaScript, HTML, and CSS, and just have Python running on the back end, handling everything else. Okay. So the widget we're going to be exploring today is a widget that explores the Lorentz system of differential equations. Don't worry too much if you don't understand the differential equations or the calculus we'll be going through. This is mainly just a final lecture to show the possibilities of constructing a full-blown custom widget or GUI interface in the Jupyter notebooks. So the Lorentz system, you can go ahead and check them out on Wikipedia. It's basically just a famous classic set of differential equations. And it's famous because when plotted for certain initial conditions, it usually makes kind of a nice figure 8 or butterfly pattern. So that's what it's famous for. So we're going to try to see if we can kind of get this sort of similar animation here from the Jupyter notebook that we see in Wikipedia. And we'll be using some scientific libraries in Python and some statistical libraries, as well as some just general libraries used a lot in data science. So this is going to serve as a nice introduction to some libraries that you'll use a lot in some other courses, such as the Learning Python for Data Analysis and Visualization course. So I'm just going to walk through what we're going to do here. First, what we need to do is a bunch of imports. So I'm going to go ahead and jump over to the live code where I've actually already copied everything. So I'm just going to walk through what each line does. This matplotlib inline. So matplotlib is a plotting library in Python. And what it allows us to do is just do basic plots in Python. And this specific line, matplotlib inline, is the line that allows you to see matplotlib in a Jupyter notebook. NumPy is a linear algebra library for Python. And SciPy is a scientific computing library for Python, used a lot for statistics. And here we're importing a bunch of other stuff from matplotlib, just particular animations, color map names, 3D axes, and then just general plots. So continuing on, we have the other imports that we've been discussing throughout this section: IPyWidgets, interact and interactive, and then IPython.display, clear output, which will clear the output, display, and HTML. So here what I've done is we have a basic function that goes ahead and solves the Lorentz system of equations and then plots them as basically you change the parameter time. So these three lines right here basically set up a figure to be plotted, adds access to it, states it's a 3D projection, and then this dot axis off basically turns off any 3D representation of axis. So we just get a white background. We set the axis limits with this set of commands, set limits. Here, we're basically computing the time derivative of the Lorentz system. So that just solves, this system of equations up here. And then going back, we just choose a random starting point. We uniformly distribute them from -15 to 15. So here you can see we're using NumPy imported as NP. So that's where NumPy is coming into play. We also use it to solve for the general trajectories. So time and xt. Then we choose a different color for each one. Here I'm calling a color map jet. And then what this does, it basically just plots the lines. So what I'm going to do now is just call this whole function here, solve Lorentz. Click Shift Enter, and you can see we've solved it for this particular set of conditions. I can go ahead and change this angle and maybe make a few less lines. And here you can see there's some less lines. Let's just put in 2. Here we have 2 lines. Let's put in 15 and maybe a larger angle here. Well, let's go just really large so we can see the difference. How about, let's say 65, and we'll put in 20 lines. Here you can see that's quite different. So we're just putting in a bunch of things to the Lorentz equation. And now what I'm going to do is pass it into the interact widget that we've seen earlier. And we also pass in limits. So angle can go from 0 to 360. N can go from 0 to 50. Let's go ahead and make that a little smaller so it doesn't get too crazy. We'll say it goes from 0 to 25. And then we also have 2 other parameters, sigma and rho, which have to do with the inputs here, rho and sigma, which are part of the equation here. Here's rho, here's sigma. So we can go ahead and run this and interact. We'll basically turn these all into floating point or integer sliders that we can interact with. And I'm going to zoom out so you can see the full picture here. And now I can interact, and it'll update the figure thanks to the widgets. And I need to keep max time to a certain amount. I can increase sigma, decrease the number of lines, and it'll update it as I change it. And I can actually change the viewing angle. So you see here, it's basically just being animated. I'm just turning the animation with this widget. And it's also updating all the arrays you're seeing here. So we can increase sigma, decrease max time, increase max time. That basically just says how long these lines are allowed to run. Increase the number of ends, decrease or increase rho. And you can see how the plot changes. Okay, so I hope this gives you a good idea of the power of widgets, and hopefully you've started to think about if these are useful to you, maybe in a work setting or in a hobby setting, how you would use these widgets on your own. Maybe you have some sort of task that coworkers do every day that you'd like to automate it. You might just make a widget for them to fill stuff out and see the results. You never know. But hopefully you've seen the power of GUIs, at least the ones that are available in Jupyter Notebooks. It takes a long time to learn how to use these widgets really effectively, so take your time when you're learning them. I know I kind of threw a lot of stuff at you, especially with all these libraries that you may not have experienced before. But really, this is just the end of the bonus section, so it's up to you to go ahead and explore what interests you. If web development interests you, go ahead and go with Flask or Django. If you're interested in developing data science skills more, you can check out Learning Python for Data Analysis and Visualization. Really, the whole world is open to you now that you know how to program in Python. You can solve any of your problems, well, at least a lot of your problems that have to do with automation with Python programming. So I really just hope you've enjoyed the course. Good job getting all the way to this point. Congratulations. You should be proud of everything you've learned and accomplished. And I hope you've enjoyed the journey. All right. Thank you, everyone. Hello, everyone, and welcome to the widget styling lecture. So in this lecture, we're going to learn about the various ways to style widgets. So as you can see here, I have downloaded the widget styling corresponding notebook, and I went ahead and ran the first cell, ipywidgets as widgets, and ipython.display import display here. So there's basic styling, and the widgets distributed with IPython can be styled with these following traits: width, height, various colors, borders, widths, and styles, and also the font, style, weight, size, and family. So you can mess around with the width and height, the basic background color, the border colors, and then the font parameters as well. So for example, here's an example of what a button widget can be styled as. So we can see we've set button equal to widgets.button, and then we've took description, set it equal to hello world, and then we could set up all these parameters here as far as describing how it's going to be stylized. So you can add these parameters to most of the widgets available to you, and you can start styling them. Okay, so you can see here, I've set the width equal to 100, height is equal to 2 EM. EM is a valid HTML unit of measurement. So having a knowledge of CSS and HTML will definitely help you understand styling here a little better. And then we've set color to lime. You can also set colors by name. And then we've also set background and border color. And then I'm going to display the button. So here it is displayed. And let's go ahead and change some stuff around so we can make sure it's actually taking effect. I'll set the border color equal to red. I'll set this color equal to green. I will change the description to say change. And now if we run it, you can see there's some slight changes there. You can also select colors by the color code, or again, just straight text. Now, not every single name will work, but most common color names will as strings. All right, let's go ahead and close that. So I also want to mention parent-child relationships. So to display, for example, widget A inside of widget B, then widget A must be a child of widget B. And widgets that can contain other widgets have what's known as a children attribute. So one widget is the child of another. And this attribute can be set using keyword arguments in the widgets constructor or after the construction. So calling display on an object with children will automatically display the children. So let's look at what we have here in the cell. Again, I've imported display, and I created a float slider, a text box, and then set a variable called container called widgets.box and set a parameter called children equal to these two widgets here. So note how I'm passing in the list of the widgets themselves to this children equals under box. And then I'm setting, using the property names of this container, border underscore color, style, width. So right now I'm looking at red dotted width is 3. Let's go ahead and change that to 5. And then I'm going to display this container. So what's going to happen is this container contains both of these children, this float range and the string. So if I display it, here we see this container. The container itself is only this border here, and it contains this slider and this text box. So after this parent is displayed, children can be added to the parents after it's been displayed. So note here, I have container equals widgets.box, set the container border styles, display container, and now I'm going to say integer range is equal to widgets int slider, and I'm saying container.children is equal now to this single item list int underscore range. And if I run this here, I've altered it to just have a single integer slider. Okay, so if you need to display a more complicated set of widgets, there's specialized containers that you can use. So to display multiple sets of widgets, you can use an accordion or a tab in combination of one box per set of widgets, which I'm about to show you below. And these quote-unquote pages of the widgets are their children. So to set the title of the pages, use set underscore title. Let me show you what I mean by all that. So here I have an accordion example, and then below we have a tab widget example. So in the accordion example, I have two separate widgets that follow the same format: a name, zip, page, and then we have a text, a bounded integer text, and then a box containing the two children. Same here, a box containing two children of name2, zip2. First one is just a text with description location. Second one is just a description with zip, and it can take in a number. So we have a string text, an integer text, and then a box that has them both as children. And then in order to put these together, I have the accordion feature from widgets, and I'm going to pass it children page 1, page 2, which are essentially these boxes here. So you can see I almost have like a children within children here. And I'm going to go ahead and display the accord or the accordion here, and I'm going to set the titles from and to. So if I just run this, I have this little bit of an accordion function here with the from location and the to. And then I can go ahead and fill stuff out. So I can say my location is San Francisco, zip code, let's say 90210, whatever. And then I can click here on to, and due to the accordion structure, it'll pull up to, and then say I want to go to Los Angeles or wherever, and my zip code is 789, whatever, 999, doesn't matter. Okay, so this is what the accordion structure looks like when you're trying to stack children together. You can click them open, so it's opening and unfolding like an accordion, and you can do it for both. All right, so let's go ahead and close that. And then we have the tab widget option, which you'll notice here I have a text, name, color is dropped down, page 1 is a box. Here I have an integer slider with radio buttons in a box. Take both these page 1 and page 2, which they themselves have children, remember that. I have a padding option here, parameter I should say. And then set tabs equal to widgets.tab with these two as children. And if I go ahead and run that, you'll notice I get something that basically looks like web tabs. Here are the children stacked in each tab themselves. Okay, so go ahead and read through this, these two cell blocks, make sure you understand them. But basically what's happening here is for this first section, we're passing in children to this box. And then in the second section, I'm putting these two boxes together. In the first section with an accordion style, and then the second section with a tab widget style. So that way if you want multiple widgets everywhere, you can organize them with either the accordion or the tab formats. Finally, alignment. So alignment allows us to affect how the width is assigned. So let's take a closer look at that. So let's go ahead and see a few examples of how this auto alignment works and if we need to fix things. So in this case, the text of the label is always right aligned and the widget's always left aligned. So if I run this cell, we can see here that the text has been right aligned and the widgets themselves have been left aligned. And if a label is longer than the minimum width, so you can see here this very last one has too long, it's widget's going to be shifted to the right here. So I'll have to fix that. Like so. All right, if a description is not set for the widget, then the label is not displayed. And then it fills up everything here. So you can mess around with the alignments, or you can also use what are known as flex boxes. So we can use these flex boxes, which are flexbox, hbox, and vbox widgets, to align our widgets. So for example, if we want to display them vertically, we can just actually by default, it'll display them vertically. So here I'm almost doing like a little list comprehension of 3 different buttons with the description 0, 1, 2. And I click them themselves, and they've been automatically assigned to be vertical. If I want to do them horizontally, I can use .hbox with widgets, pass those buttons, that list the buttons, as children. And here we've assigned them horizontally. And then for visibility, if we want to hide widgets, so the visible property of widgets can be used to hide or show widgets that have already been displayed. We can set it to true, the widget's going to be displayed. If you set it to false, the widget is hidden, and then the empty space where the widget should be is collapsed. And then if you just put none, the widget is hidden, and the empty space is still going to be shown. So here I've made 3 widgets with LaTeX, just first line, second line, third line. It's just text here. And if I set w2.visible, so that's the one that says second line, equal to none, you'll notice we still have a gap there. If I set visible equal to false, notice how it gets collapsed. And if I set it equal to true, it comes back. So the main thing to know here is that none will still leave a blank space there, but false will allow you to collapse those widgets. So finally, what I want you to check out by downloading this notebook is this example of a form being rendered, which conditionally displays widgets depending on the state of other widgets. So I'll break it down real quickly for you, but I want you to really download this and play around with it yourself, edit it, see what you can change about it, see how it actually works. the best way to learn these things is just by messing around with them. So the first thing we have here is a vertical box and then two texts for first and last name. So we have the form, first and last. Then we have a student variable, which is just a checkbox with a description student. Currently the value is false, so you'll be able to check that true or false. Then we have the school info, which is an object with a vertical box of children consisting of a text and then an integer text. So for a school and then for the 0 to 12th grade. And then finally, we have widgets.text as a pet, so whether or not this person has a pet. And then from the form.children, so this very first vertical box, we put it all in. We set it equal to the first, last, student, school info, and pet. So go back up and make sure you review how to assign children so this line here makes sense to you. And after that, we're going to display the form. Okay. On one of these, we call onStudentToggle. So we have a little function here. So it takes in if value, schoolinfo.visible equals true, else schoolinfo.visible equals false, and then student on trait change. So if you go back here to student, this checkbox, when this is changed here, we'll pass the value onto the onStudentToggle. So if I run this, I basically have a little cell here where I can say, put in the student's name. If they're a student, notice stuff gets toggled here. So the school info is now visible, school and grade, or whatever numbers you want. Okay. So make sure you really play around with this. Try making your own form. Maybe try putting this into a tab or something like that. Really play around with it and have fun with it. So we're almost there. On the next one, we've already seen, the next lecture, we'll dive further into a more customized example of a widget. But this is basically our first, putting it all together. This cell here is our first example of an entire widget put together. So really make sure you download this and play around with it. I purposefully here didn't go line by line to make sure that you have the time to really explore and learn all about this for yourself. Okay, so just to review, we've gone over widget styling, basic styling, fancy boxes, such as accordion and tab widget, basic alignment, how it automatically works, and how we can use flex boxes to change that if we need to. Visibility, how we can make stuff either none, false, or true as far as visibility is concerned. And then a basic example of our first real widget. All right, I'll see you at the next and final lecture for this section, where we're going to be making our own custom widget. Okay, thanks, and I'll see you there. Hello everyone, as I mentioned in some previous lectures, there's a ton of widgets, and finally we got to the widget list lecture, where we'll be giving you a reference for all the GUI widgets that are available. So for a complete list, again, you can always check out the Jupyter Notebook here. Right now I have the same notebook opened on my personal computer here. And you can see there's a complete list, and you can call it by just calling widget.widget_types.values. And that will bring you the complete list here. And it's a pretty extensive list, as you can see. There's HTML, radio buttons, boxes, text, integer text, toggle buttons, flexbox, select, normal buttons, images, etc. Integer sliders, a lot of things we've already seen. So as far as numeric widgets, there's 8 widgets distributed with IPython that are designed to display these numeric values. And widgets exist for displaying integers and floats, both bounded and unbounded. So the integer widgets share a similar naming scheme to their floating point counterparts. So integer and floating points, you'll basically see that the main difference is one starts with float and one starts with int, such as float slider or int slider. Okay, so we'll be going through the float ones here, but you can just replace wherever it says float here with int to see the integer equivalent. So let's go ahead and check out the float slider. Whoops. I need to go ahead and run this first cell. Now that they're imported, we can see here we have an integer slider. We can also display them vertically. So notice how there's a bunch of extra parameters here. Again, this is the main notebook to use for references on what parameters you can pass. In this case, for the sliders, we have a starting value, a min, a max, a step size, and then a description, which will go here at the left of the slider. And you can see the current value as you slide along. You can also pass in an orientation parameter to display it vertically, as we can see here. Let me go ahead and close that. There's also float progress bars that will load if you connect them or link them to some sort of operation or function as they take time. So keep that in mind. There's also bounded float text boxes, which, as you can imagine, would just accept floats, or float text, which is a really similar object or widget type. Notice, again, there's parameters here, so you can check this whole notebook out as a reference to what parameters are available for you. As far as Boolean widgets, there's 3 main widgets that are designed to display a Boolean value. First one is the toggle button, which here I'm just clicking it. Again, nothing's linked to this, so nothing's going to happen if I click it. There's a checkbox, which I can check on and off. And then the valid widget, which just provides a read only, so I can't actually interact with this, but I can have it display or be linked to something. Maybe if I hit a certain number, I can have this valid check mark show up. Again, this is mostly just a reference to what widgets are available, not how they can actually be used in practice. So there's selection widgets as well. There's 4 main types of selection widgets. Some of these we've already seen, such as the drop-down. So basically, these all inherit from the same base class. And you can specify enumeration of selectable options by passing a list. And you can also specify the enumeration as a dictionary, as we saw in one of the earlier lectures in this section. And in which case, remember, the keys will be used as the item displayed, and the value will be returned to the corresponding function or whatever you're actually returning it to. So in this case, if I run this, we can see the drop-down menu here show up. We have options as a parameter, pass in a list there, the value, and the description. We can show the value, and if we select another, we can show another value. I really suggest that you actually just take the time to download this notebook and play around with the widgets yourself. This is just showing you a basic reference to all the widgets that are available to you. Again, we can also pass in a dictionary. So if I call this guy over, 3 and 1, you'll notice the drop-down changes. So we saw this earlier with interact, how automatic it was, but if you want to get more specific or more control over your widget, you can use this sort of syntax. There's also radio buttons available for you. Radio buttons just look like this. So here I have pizza toppings to be chosen that you can fill in as a radio button. There's also select. So you can select these. Here I just have selections. There's toggle buttons, which will just allow you to toggle things as a widget. Remember, these are all widgets. They have to be connected to something or some sort of function to actually interact or have some sort of response. And then there's also select multiple, which is really similar to this select, except for select multiple, I can highlight using shift or unhighlight using command or control, depending what your operating system is, just like you would be able to on a select multiple list. So using shift or control or command, you can select multiple ones, and you can also operate it with your mouse keys. All right, and then we can see pairs. Since I'm on pairs right now, if I select oranges, I'm on oranges for the values. String widgets, there's about 4 widgets that can be used to display a string value. And then of those, the text here will accept an input. So I can say, "Hi everyone," exclamation mark. And then there's text area, which will just give me a larger area to type in some text here. And you notice it'll expand as I click enter and need more room. LaTeX will allow you to type in LaTeX commands. So if you're familiar with LaTeX notation or how to write it, you can use the .latex. HTML will allow you to put in HTML. So you can notice here, if you're familiar with HTML, I'm bolding the world here. Or I can put it in italics. I believe it's emphasis here, EM. And you can see now it's in italic. So if you know HTML, you can use this to your advantage. And finally, there's a button, which we've already seen in the past. Okay, so the main point of this lecture is just to introduce you to the variety of widgets that are available to you. If you ever want to see them all, you can just run this cell or reference this Jupyter Notebook. And you can also reference the variety of arguments you can pass into all of these widgets. All right, that's it for this lecture. What you should really do is just download this notebook and play with it yourself and make sure you understand how each of these widgets actually operates and what it provides to you as far as options. All right, that's it for this lecture. In the next lecture, we'll be going over a brief overview on widget styling. So you can actually get a lot more customization out of the styling and what the widgets physically look like on the screen. Okay, thanks, and I'll see you at the next lecture. Hello everyone, and welcome to the Widget Events lecture, part of the GUI section of this course. So in this lecture, we're going to discuss widget events. The events can be something like a button click. So you can see I've already imported some stuff here. From the future, imported the print function and imported ipywidgets as widgets. So let's go ahead and start with special events, such as the button. And if you go to the Jupyter Notebook that's already available for you, just want to remind you, everything we're going to do is available for you to see here in the Jupyter Notebook. And I may be copying and pasting from this notebook to save on some typing time. But I was mentioning earlier, the button is not used to represent an actual data type. Instead, the button widget is used to handle mouse clicks, as you might expect. And then the button has an onClick method that can be used to register functions to be called when the button is clicked. And we can actually see more details on this by printing out the document statement. So I can say print. Remember, I'm using the print function, so this is Python 3 notation as far as printing goes. And I can say button on click. Notice I'm pressing tab here to see everything that I have available to me. And then I'm going to go ahead and say doc to print out the documentation. So we can do this, and we can see that register a callback to execute when the button is clicked. So let's go ahead and see an example of the button clicks. Since button clicks are stateless, they're transmitted from the front end to the back end using custom messages. So front end is what we see, back end is what we're actually typing out. So let's go ahead and check this out. We can say from ipython.display import display. And then I'm going to set button, just the variable name button, equal to widgets.button. And I can pass a parameter here called description. And this is what the button's actually going to say. So in this case, I'll have the description say, click me. And then I can actually display the button. And I'm going to continue in the same cell. I'm going to write out a function called onButton_clicked. Takes in b, some variable called b. Doesn't really matter in our case, and it's just going to print out button. Let's say button has been clicked. And then finally, after all this, I can call that button object, that variable, and say onClick, call that function, that on button clicked. So if I run this, I see a button show up. Notice how I can actually click on it, and then we get something gets printed there. The button has been clicked string. So let's review what happened in the cell real quick. I created a variable called button, and I set it equal to widgets.button. So that grabs the button widget from the widgets library. I pass in a parameter called description equal to click me. That's what the button says. I said to display the button, and the button's not going to do anything unless I say call a method onClick and then pass the function that I want to occur there. And then onClick, it calls here, and it prints out the button has been clicked. So I can also have other methods, such as, I'm going to close this right now, onSubmit. So the text widget has a special onSubmit event. So right now we're just talking about special events that are particular to certain widget types. So in this case, I can make a text widget, and that's just calling text from the widgets. Remember earlier we actually imported everything from the IPy widgets, so we were just able to call text here. Since I just imported widgets, I have to call it from widgets. And then I can display text. I'm going to make a function called 𝗓𝗛𝗄_submit. It takes in an argument sender, and then it's going to print text.value. So it's going to print basically whatever the value of that text cell is. So then I can say text, and the special event is going to be onSubmit _submit. And what this actually does is the onSubmit event fires off when the user hits return or enter on your keyboard. So I can say hello, and this actually will, once I click enter here, clicked it a few times, let me try it again to say like dog or something. Every time I click enter, it's going to call the special event onSubmit, which has that enter feature built into it. And it's going to call 𝗓𝗛𝗄_submit, which just grabs the text and spits out the value, which is whatever you put into the text box there. All right, now let's talk about traitlet events. So we saw traitlet when we were trying to link things together. Widget properties are basically IPython traitlets, and the traitlets are eventful. So to handle changes, there's known as the onTraitChange method of the widget can be used to register one of those callbacks. So the doc string, I can actually print it out for you guys. I'm going to go ahead and copy it from the Jupyter notebook that's already made for you guys. So you can go ahead and check out the document string, but what it does is just sets up a handler to be called when a trait changes. So let's go ahead and see this by example. So I'm going to make a variable called int_range, set it equal to widgets.intSlider. So I'm calling the integer slider from widgets. Remember, if I had imported everything or with the asterisks, I could have just called intSlider. I'm going to display that object int_range. Then I'm going to make a function, and I'm going to call this function onValue_change. And it's going to take in a name, a value, and it's just going to print out the value. And then here what I'm going to say is int_range. I'm going to call on_trait_change, what I mentioned earlier. And then it's going to call the onValueChange. And I'm going to pass in a string labeled value here. So you'll notice what happens is it's actually calling or printing out whatever we have here as the value. So I have onTraitChange. It accepts the function, and in this case, we want to also pass in that value. So it's going to print out whatever value. This is going to get a little sloppy. So let me go ahead and close that off and run this again. So you'll see as I slide this, it's going to go ahead and print out the values that I'm sliding on. One more time. If I go all the way to 100, it's printed out all those numbers. Okay, great. So now let's think about linking widget attributes together. So we saw a little bit of link before, and we did it from 𝗓𝗏𝗧, so I can say import 𝗓𝗏𝗧. And what I'm going to do is show you a couple examples of linking 𝗓𝗏𝗧's attributes, and this is happening server side. All right, so let's go ahead and see an example of this. And in this case, what I'm going to do is actually copy and paste from the existing Jupyter Notebook. So if you go to the Jupyter Notebook for widget events and scroll down, what I'm going to be doing is copying and pasting these two examples here from linking 𝗓𝗏𝗧's attributes. All right, so the first one I'm going to copy is that first cell example. And let's go ahead and break it down before we run it. So what I have here is I have a caption, and the caption is equal to widgets.latex. So if you're unfamiliar with LaTeX, it's basically a way of writing out mathematical equations. In this case, we're actually just putting in straight LaTeX as text for the way it's going to be accepted here. And then I created two variables called slider1, slider2, and we have widgets, and then again, we're just calling integer slider with a description slider1, slider2 as parameters. And then as we saw earlier, we're linking them up using 𝗓𝗏𝗧.link. And I'm passing in that first slider1 with value and slider2 with value. And then we can display them both. So if I click Shift Run here, notice how they've been linked now. So if I move one and another, they're synchronized. Okay, let's go ahead and see another example of this. So I'm going to go ahead and grab the text from this second example and paste it here. So if we just run this cell to see what happens here, we can see we have a source and then a target. And only one affects the other here. And that's because we're using something called 𝗓𝗏𝗏𝗏. So this 𝗓𝗏𝗏𝗏𝗏 function allows us to have source values reflected in a different target. So again, we have widgets.latex, which will just basically print out any string you put in here. We created the sliders, integer sliders, source and target. But with this 𝗓𝗏𝗏𝗏𝗏, we have the source linked to the target here in a manner where when we display them, we can move the target around and the source won't change. But when we move the source, the target will change. Okay. Finally, you could also unlink these by calling a .unlink method on either DL or L, depending on how they've been running. All right, so I already closed them up. Last thing we're going to learn about is linking widget attributes, what's known as from the client side. So when you're synchronizing these 𝗓𝗏𝗧's attributes, you may experience a lag because of the latency due to the round trip. So for example, if I grab this one and move it fast enough, you'll notice there's a little bit of lag here. It's a little hard to tell in this video. But if I probably run it here, you'll notice there's a little bit of lag as well. It's a little hard to tell since I'm running them so quickly, but the way to get rid of this is by using the .js link, which will directly call JavaScript to directly link the widget attributes in the browser. So this has to do more with how Jupyter Notebook actually displays these widgets using JavaScript as a front end here, or excuse me, displaying these widgets using the .js link. But if you go here to the notebook and check out these examples at the very end with the no lag versions, they'll be using .js link, and you'll see much less lag than in these first two examples. Now on some computers and some browsers, you won't actually notice lag at all on either one, but if lag is important to you, you should probably use this .js link as a precaution. There's also a .js 𝗓𝗏𝗏𝗏, and you can unlink them again just by calling the unlink method. Okay, so this was just an introduction to events. Let's just go over quickly what we learned here, or what we were introduced to here, I should say. We were introduced to special events, such as a button on click, where you can have things happen when a button is clicked, and on submit, when you can, on submission, when a user hits enter, perform some sort of function. Okay, and then we had traitlet events, which helped us link widgets together. All right, that's it for this lecture. In the next lecture, we'll be learning about what we call the widget list, which is just the list of all the widgets. All right, I'll see you at the next lecture.